let's look at our next set of logic. And 3.4, we're going to look at verifying arguments, and this is going to be a fairly short lecture. If I want to verify an argument is a series of statements, not yelled at one another, that has premises with a single statement called the conclusion. An argument is valid when all of the premises are true, and because all of those are true, then the conclusion must also be true. And you'll notice the dotted triangle that occurs is how we're going to indicate that something has a conclusion. In order to verify an argument, there are a couple steps you need to follow. You need to make a truth table. You need to examine only the lines in the table where the premises are all true. If the conclusion is also true for the lines you examined in step 2, then the argument is going to be considered valid. If the conclusion is false, even one of the lines that you look at in step 2, then the entire argument is invalid. So it's kind of like defaulting to a place where you're saying you said something that was a prerequisite and that prerequisite was false. So if you buy a more expensive Hulu plan, then you can watch commercial-free TV. You cannot watch commercial-free TV, would be the negation. Therefore, you did not buy expensive Hulu plan. So notice that first statement is true, but the second statement is false. And because one of the premises is false, the entire thing is going to be false. So if you're going to let E stand in this example that we're given for you buy a more expensive Hulu plan, and then F stand for the secondary section, then the argument would look like the below piece. That would just be the mathematical notation for what we just said. And then as you're filling out the truth table, the key is not to look at this as E and F and not E and not F. It's to state the statements in your head. And that will help you fill out the truth table. You always have to root your truth table in what's happening in the real world. If I want to look at an invalid argument, what does that actually look like? If I have the new calling plan, then I can text my friends for free. And then I have the statement, I can text my friends for free. Notice how I'm taking the second phrase of that conditional. Therefore, I have the new calling plan. So I'm just breaking up that if-then into the concluding statement. Therefore, I have the new calling plan. So if I represent this, I'm going to see if C, then F, and then F, therefore C, which is just what I went over. To make the truth table, you're again not going to think about C's and F's and not C's. You're actually going to go through with the phrases and do the activity with the phrases. So if you look at valid forms and fallacies, these are some of the laws that happen. And fallacy means places that we could be following the mathematical rules, but still wind up with a weird situation that doesn't fit in the law. So let's look at trying to identify the form of an argument. So if I want to identify the form and state whether it's valid or invalid, let's look at the next example. If you want to improve your cardiovascular fitness, then take up cross-country skiing. Then I take up cross-country skiing, therefore I want to improve my cardiovascular fitness. So if I wrote this out mathematically, this argument would look like if I, then C, C, therefore I. This is a fallacy of the converse, which is an invalid argument form, because you don't know if someone took up skiing for their cardiovascular health. Maybe they enjoyed skiing. Maybe they are moving to a place where skiing is popular. There are lots of other reasons I could do that. Here's another example. If you sleep through your morning math class, then you will be well rested. If you are well rested, then you will do well on your math test. Well, again, we're falling into kind of a tricky space here because sleeping doesn't mean you know the content. And so this is a syllogism and it's valid even though the reasoning doesn't quite make sense. And that has to do with the if-then statements and then the therefore statement being true. Now remember, we said we can't understand this as if someone doesn't go to their test, then they fail. Remember, we can't make that assumption. We can only say the assumption is if somebody sleeps through the morning math class, we are assured they're going to fail because they're never even going to take the test.